Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we erupt weird and wonderful science over your brain. I'm Ian Woolf. From 2008, on this edition, Graziella Caprarelli talks about space volcanoes. But first up, here's Google reproducing an experiment. Google Wars. Google has been secretly experimenting on Australian people as part of its war with the Australian government. The Australian federal government has announced that its Liberal National Party donors, the two big Australian media companies, Fairfax 9, which is run by ex-Liberal Treasurer Peter Costello, and News Limited, which is run by Rupert Murdoch, are getting ripped off by Google. They allege Google makes money from ads displayed around their news on the Google search page, and that Google should pay some of this profit to Fairfax 9 and News Limited. The two big news companies have a virtual monopoly on TV, radio, newspapers and internet news in Australia. You can choose to look at independent news online, but you're less likely to find it without effort. On TV, there's nothing else except ABC. On radio, there's ABC and community radio. And in newspapers, there's a few small alternatives, like the Saturday Post. Google has responded by secretly running an experiment where some Australians cannot see any Australian news sites come up in their Google searches. Google admitted that about 1% of users had Australian media sites blocked in their news searches without consent or notification. The Australian government has excluded the ABC, the Australian Broadcasting Corporation, from getting any payments for reuse of its journalism, but Google censored them anyway. Even Australian outlets of foreign news services like The Guardian were blocked. The Liberal National Australian Government does not have a love and respect for journalism and its place in informing citizens in a democracy, or they wouldn't keep setting the police on journalists and they'd advocate for Julian Assange. But they do have an interest in keeping their donors happy. Google abusing the trust of their users by deliberately corrupting search results is reminiscent of when Facebook deliberately manipulated some users' feeds in an experiment to find out if they could induce depression. Facebook never answered why they wanted to make some users feel depressed, but the experiment was successful. It's bushfire season in Australia and a pandemic. People rely on Google to help them navigate to safety and to find places they should avoid and when to get tested. By secretly censoring all Australian media sites, Google have risked people's lives. It's quite an abuse of power. In this case, we know that Google is abusing users as part of its fight not to pay Fairfax 9 and News Limited for the news it previews on its search pages. Google's argument is they're directing extra clicks towards the news companies, thus raising their revenue so they shouldn't have to share any of the profits that they make off the back of the news companies. It's win-win. However, many people would normally see a preview of a photo, headline and paragraph from the news story on their Google search and never feel the need to click through to the news company's website. This is just like on Facebook, where most people comment on posted article links without ever clicking through to read them. Even worse, Google doesn't just show a summary of the content, but they display on the search page a suggested list of questions with Google summarized answers, so that you don't need to click through to read the article. This is part of the general trend online that everyone wants to profit from news, but nobody wants to pay journalists to produce it. It's a pretty dirty tactic to attack Australian users at a time when Google is supposed to be in good faith negotiations with the Australian Consumer and Competition Commission. Google has argued that people's experience of searching would be undermined if Google had to pay for the news it profits from, without being able to explain how this would happen. Arguably, by unethically using Australian users as guinea pigs in a censorship experiment, Google has already undermined its search service. By an amazing coincidence, Google just happened to perform an identical experiment blocking Spanish users from seeing news from Spanish media in 2015, when the Spanish government passed laws requiring profit sharing with Spanish news companies. Once is an experiment, twice is a standover tactic. Google used to run the PageRank algorithm. Google would index the web. That meant that Google profited from websites by advertising around their search engine pages, and websites benefited from users finding them and clicking through to their websites. It was a mutual benefit. The algorithm would know which pages people clicked through on a particular keyword search, and those pages would get a higher rank and be shown at the top of future searches. This was wonderful for users and let people navigate the growing web with ease. With a little talent, you could get results in seconds, and the world's knowledge was at your fingertips. The Google search experience has been getting worse and worse for years. Now, the algorithms corruptly show you results from organisations that bribe Google to show them at the top of searches or to hide their rivals. The algorithms get arbitrarily changed all the time so that the same search no longer gives you the same result. And if I use keywords for searches, I will be shown a different result to you using the exact same keywords. Many social media sites are no longer being indexed by Google, so you can't search for anything posted there. Less and less of the web shows up in searches. What used to be an easy, effortless interface to the web has become a corrupt, inconsistent service that can frustrate more often than it enlightens. Google taking down their "Don't be evil" sign may have been the last honest thing the company has done. Google has also decided to share much less of their profits from YouTube with content creators, destroying what used to be an alternative independent media career path. Individual content creators on YouTube now rely on fan funding sites such as patreon.com/diffusionradio instead of advertising revenue shared from Google as they once could. News media used to be free or cheap and make running costs and a profit from advertising. Google took over online advertising completely and made it so massively cheap that media organisations couldn't make a profit anymore. Now many of them either ask for donations, paywall their content for subscription fees, or are the playthings of billionaires. The Media and Entertainment Arts Alliance, the Australian Journalists Union, said that the business model of Google and Facebook has literally destroyed newsrooms around the world. The Australian government estimates that for every $100 spent on online advertising, $53 goes to Google, $28 goes to Facebook, and $19 goes to other media. Two of the wealthiest companies in the world, Facebook and Google, would rather deny services to Australians than pay for the journalism they profit from. Google has demonstrated that it can't be trusted to bargain in good faith. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. In 2008, I was paid to interview some University of Technology Sydney scientists as part of the Science Communications Education Project. Graziella Caprarelli is a space scientist who is researching space volcanoes in the UTS Department of Environmental Sciences. When robots visit other worlds and send back pictures, the data goes to Graziella. I began by asking her, what does she look for?
I started by looking at volcanic activity on Earth, and then I realized that there were many similarities between some of the volcanics that I studied on Earth, even in Australia and those in North America, and I realized that on Mars we have similar type of volcanic activity, and so I decided to expand there. That was fun.
Terrific. So how do you look at the volcanoes on Mars? Is it all through telescopes?
No. We use orbiters. So there are all these missions that NASA and ESA send to various planets in the solar system. And I use the data that the orbiters relay back to Earth. So we process the data and then we interpret them.
So you can see signs of volcanic activity through the orbitals?
Well, on Mars, we do not see any sign of activity at the moment because there's none. Mars is relatively more ancient than Earth, but there are signs that activity has lasted until very recent geological times. And so that makes it very exciting because we always thought that Mars being smaller than Earth, then it would have exhausted its thermal engine very, very quickly. But in fact, we have found that rocks on Mars are of volcanic origin are even as young as 10 million years. So that's very, very young for what we thought. So all these orbiter studies are actually telling us quite a lot of things that we did not know about Mars or about which we had misconceptions. And they provide important information because they let studying Mars also helps us understand more about Earth.
So how do these orbiting robots actually tell you information about the rocks?
It's satellites. So basically what happens is that they take images. So they have payloads on board, and there are a number of instruments that each satellite carries. So they clearly take lots of images in various spectral frequencies as well, so we can also tell about the composition of the surface. And they also have various equipments that measure the elevations on the surface, so we see the shape of the surface as well. We are able to measure the gravity field, so the gravity field tells us about the distribution of masses inside the planet. And we also have data about the magnetic distribution of the distribution of magnetic anomalies that also gives us information about the rocks. So when you piece together all this evidence, then if you know about how things work on Earth, then you can extrapolate that knowledge to understand how Mars works and what's on the surface.
And you look at other places in the solar system as well.
Well, personally, I have not yet attacked any other planet, but I know that Venus also has quite a lot of volcanic activity. It's very well documented. There have been also landers on Venus. The most successful people to land on Venus, always by robots, were the Russians. We are currently in the process of collecting more data about Mercury, and naturally there is all the evidence about the volcanic activity, for example, on the Moon in the past, and one of the Jupiter moons, Io, also has quite a lot of it. That's a different origin from the volcanic activity that we have on Earth, but it's still volcanic activity. So yes, the orbiters and all the probes that we have sent through the solar system are in fact telling us quite a lot of interesting things about volcanism, and that it's not just only the type that we have on Earth, but there are a variety of flavors there, and that's very important to study them.
And you also look into astrobiology?
I think I gave a seminar a few weeks ago, actually, at Macquarie University, where I was told to talk about astrobiology, which is not my area of expertise, of course. But the bottom line there is that in order to look for life on Mars, you have to consider that the geology is very important, because the reason why we have life on Earth is because of all the volcanic activity that warmed up the atmosphere and created a greenhouse effect. Otherwise, the surface of Earth would have been too cold to have liquid water. And we now know that liquid water is important for the sustenance and evolution of life. So geology is the number one factor to some extent, if you want to have an idea of whether a planet will sustain life or not.
So by looking at the volcanic activity, you can tell the water and whether or not life is possible either in the past or still around?
You can make some educated guesses.
So Mars has volcanism in its distant past, but
Yes.
it may have water now, is what the latest information is.
Well, certainly there is water, whether it's in its liquid phase or not, that's another story. Certainly there is ice on the surface, because the surface of Mars is very cold. Even when it's hot, it's cold. And but naturally underground, where you can increase the pressure because of the rock layers on the top, then this ice can in fact be melted and become liquid water. The real question is, was there enough liquid water free-flowing on the surface to promote the evolution of life as we have seen it on Earth? Even in its primitive form, you still will need abundant masses of water, like on lakes or on oceans. That is the debatable issue, not whether there was water on Mars or not, because we know certainly there is some. There is certainly ice. There are other volatiles. There's CO2 also as ice. But was there in the geological past all this free-flowing water on the surface for enough time so that life could have evolved? That's the big question. And certainly studying the geology and seeing how the surface was and the landscape of Mars has evolved will provide additional information in that sense. We will know whether some valleys were crafted by rivers or whether some impact craters could have contained lakes. That's all going to be reconstructed based on our observations and interpretations of the geology of the planet.
And have you looked at volcanic activity in the past on the Moon?
Personally, I haven't, but my professor in Italy was one of the persons that got the rocks from the Moon and studied them. So yeah, the volcanic activity on the Moon is definitely much more ancient. Like, the Moon is a very small body, as you can imagine, and the youngest volcanic activity that we have reconstructed is the one in the so-called Maria, which means, in Latin, mare means sea. It has got nothing to do with oceans, obviously. There was no water there, but when big impact meteorites hit the surface of the Moon, since the Moon is such a small body, it melted some of the crust and part of the mantle, and that's what created this molten material that then erupted on the surface and created these very big expanses. So that would be the most recent volcanic activity on the Moon, but that's also quite ancient if you think about it in terms of geological life as well, because the big impact in the solar system ended about 3.9 billion years ago.
So if Io, the moon of Jupiter, is still volcanically active, does that mean there's any chance of life evolving there?
No, Io is too close to Jupiter. The reason why Io is volcanically active, as I mentioned earlier, is different from the reason why Earth is active. Earth is volcanically active because it has a very hot interior. The same reason that Mars would have been volcanically active in the past. With the Moon, we've already seen there are other mechanisms in place. With Io, the reason why Io is volcanically active is because it's so close to Jupiter, which has a massive gravitational field. And so because of tidal forces, these tidal forces are in fact breaking to some extent the surface of Io. They are deforming this little satellite. And that creates friction. Friction is dissipated by heat, and that's what creates the volcanic activity on Io. So you have a variety of material erupting from Io, which is not like the basalt rocks that we see on Earth, for example. It's sulfur and all other kinds of material that's coming out. Tidal forces are very important especially in the outer solar system, where you have the giant planets. Even some of the moons of Saturn, they also are very small relative to their primaries, and obviously there is lots of tidal forces there that also create tectonic activity, not only volcanic activity. So you have large trenches, you have big faults that on Earth are associated to plate tectonics, for example, but on those little satellites they're associated to tidal forces.
Where would you like to see us explore next? Where haven't we got data from that you'd like to get data from?
Well, the real issue for me would be that at the moment we have lots of orbiter data. But like any good orbiter data, like the satellites on Earth, we often need to do ground truthing. So what we're really missing at this point in time is to have some data from the surface. And by this I mean humans walking on Mars, for example. I don't know when that will happen. If it will happen in my lifetime, I hope so, because I need the data. But that becomes more and more a necessity, in my opinion. Naturally, if you plan for human missions, then you have to cut down on scientific missions, and that's also not very good because finances are only, in a certain amount. But there are some open-ended questions that, in my opinion, can now only be addressed if we really have a first-hand look at the planet. Doesn't have to be for too long or doesn't have to be everywhere, just to have some firm points in some key areas.
Graziella, thank you very much.
Thank you.
That was Graziella Caprarelli in 2008 talking about space volcanoes. Graziella is now a professor at the University of Southern Queensland and the International Research School of Planetary Sciences. And finally, from 2008...
And now we have Ian Woolf with How Enough is Never Enough.
There's new reports that people sense the scarcity of whatever they desire. So they've come up with an experiment to give people a reason to desire one or another of two things. Then they show you an equal mix of the two things and ask you which you see more of, what you desire or what you don't desire. And people hallucinate less of what they really want, even if there's exactly the same amounts of the two things. Zhanchai Dai, Klaus Wertenbrock, and Miguel Brendel from INSEAD, the International Business School with campuses in France and Singapore, have been studying what they call the value heuristic. An heuristic is a rule of thumb that we use when we don't have enough information to make an informed decision. The connection between scarcity and value is, of course, the basis of economics. Gold is considered precious because it's rare, not because it makes a good construction material. The psychologist suggests that we've learned this lesson so deeply that we automatically make the inverse logic, that what's valuable must be scarce, even when it's not true. To test the theory, they had a group of young people view 100 pictures, half of birds and half of flowers, in random order. Then they told them that they'd get paid a few cents for either a bird picture or a flower picture. To determine whether a participant would be paid for a bird or flowers, they'll let each one flip a coin. Before being paid accordingly, all the participants were asked to estimate the total number of bird pictures and the total number of flower pictures they'd seen. The results were unambiguous. People paid for spotting flower pictures thought there were fewer flowers than birds, and likewise, those who were made to value birds determined they were scarcer than flowers. You might have expected they'd overinflate the number of the things they'd get paid for, but nobody knew that there were exactly the same number of flowers and birds. In effect, the experimentally induced yearning caused them to wrongly perceive scarcity. They hallucinated scarcity where there wasn't any. So if you really want something, there's a tendency for you to think you can't get enough of it. We don't know whether this is culturally ingrained or whether really wealthy people just don't feel this. People viewing pictures of men and women also tended to believe there were fewer of the opposite sex even when there were equal numbers of each sex. Obviously they're assuming everybody's heterosexual. To increase the validity of their findings, the scientists ran other experiments. In one, participants of both sexes viewed portraits of men and women, some attractive, some not. When questioned later, both men and women believed there were fewer attractive people of the opposite sex than there were of the same sex. If the portraits were unattractive, they tended not to perceive a sense of scarcity. Just as in the first experiment, the subjects appeared to be substituting their emotional desire for calculation and ended up believing that what they wanted was less likely to be found. So the lesson is your heart's desire may not be as scarce as you think. We may really be living in a world of plenty.
That was Ian Woolf with Scarcity is Just an Illusion.
Hi, I'm Gates McFadden, and I played Dr. Beverly Crusher on Star Trek The Next Generation. And I know Dr. Crusher very well, and I am sure that when she's off duty, she would urge you to listen to Discovery, the national science program on 2SER FM. Make it so.
And that's all from us this week on Diffusion. Subscribe and like to the Diffusion YouTube channel at youtube.com/c/Diffusion Radio. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate this show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. The news music was Rhinos Theme by Kevin MacLeod of Incompetech.com. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including Radio Blue Mountains 89.1 FM in New South Wales, 8CCC in Alice Springs and Tennant Creek, 2 NVR in Nambucca Valley, 3 MBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7LTN in Launceston, Tasmania, and 2XXFM in Canberra. Diffusion is narrowcast on Indigo FM 88 in northeast Victoria. Diffusion is syndicated globally on the National Science Foundation's science360.gov internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 1,000 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Make a donation through paypal.me/IanWolf or join my patrons at patreon.com/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.